Nos une la diversidad, nos une la FIL, Unión Europea, invitada de honor, del 25 de noviembre al 3 de diciembre en Expo Guadalajara.
¿Cómo te imaginas el futuro? ¡Espera! ¡Antes! ¿Cómo imaginas el pasado?
¿Cómo hacer lo que haces hoy, pero
sin tabletas,
sin celular,
sin internet?
¿Cómo eran los objetos?
¿Qué pasaba al usarlos?
¿Cómo escribían una carta?
¿Cómo veían su programa? ¿Cómo se divertían?
¿Cómo hacían las historias? En fin, niños,
explora.
Infinitum, exceso de velocidad.
Vamos a dar inicio. Buenas tardes a todos, bienvenidos, distinguidas autoridades, estimados investigadores y apasionados seguidores de la astronomía. Es un honor y un placer darle la bienvenida a la 10ª edición del Coloquio Internacional de Astronomía, Universo y Sociedad, que se celebra como parte integral de la Feria Internacional del Libro de Guadalajara. A lo largo de la última década hemos tenido el privilegio de explorar las maravillas del cosmos y examinar el fascinante entrelazamiento entre el universo y la sociedad. En esta edición especial del 2023, nos sumergiremos en los notables avances de la astronomía de los últimos 10 años. Nuestra programación está llena de distinguidos invitados, todos ellos científicos de primer nivel, provenientes de diversas universidades e instituciones alrededor del mundo. Vamos a tener a lo largo del evento una conferencia magistral, 2 mesas redondas que prometen ser foros muy enriquecedores de discusión y culminaremos con una conferencia de clausura, que sin duda nos dejará reflexionando sobre el fascinante mundo que habitamos. A continuación, me complace presentar al distinguible presidium que hoy nos acompaña. El doctor Marco Antonio Pérez Cisneros, rector del Centro Universitario de Ciencias Exactas e Ingenierías. El doctor Óscar Blanco Alonso, director de la División de Ciencias Básicas del Centro Universitario de Ciencias Exactas e Ingenierías. El doctor Gilberto Gómez Rosas, jefe del Departamento de Física del Centro Universitario de Ciencias Exactas e Ingenierías. El doctor Héctor Hugo Ulloa Godínez, director del Instituto de Astronomía y Meteorología de la Universidad de Guadalajara. El doctor Alberto Nigoche Nectro, coordinador general del coloquio. Y la licenciada Laura Niembro Díaz, directora de contenidos en la Feria Internacional del Libro de Guadalajara. Ahora cederé el micrófono al doctor Héctor Hugo Ulloa Godínez, director del Instituto de Astronomía y Meteorología, quien nos dirigirá unas palabras de bienvenida.
Bien, buenas tardes. Buenas tardes a todos, a todas las personas que hoy nos acompañan. Doctor Marco Antonio Pérez Cisneros, rector del Centro Universitario de Ciencias Exactas e Ingenierías, estimados miembros del Presidium, amigos todos, es un honor para la Universidad de Guadalajara, para el Centro Universitario de Ciencias Exactas e Ingenierías, para la División de Ciencias Básicas, el Departamento de Física y el Instituto de Astronomía y Meteorología, al cual represento, darles la más cordial de la bienvenida a esta inauguración del Coloquio Internacional de Astronomía, Universo y Sociedad, que cumple su 10ª edición en el marco de la Feria Internacional del Libro de Guadalajara 2023. Una vez más, nos reunimos en este espacio de encuentro entre profesionales de la astronomía, estudiantes y el público interesado en esta apasionante ciencia. La edición 2023 se centra en el tema 10 años de la astronomía en la FIL. Este evento anual nos ofrece nuevamente una oportunidad para analizar y discutir conocimientos relacionados con la exploración de los planetas, los acontecimientos más importantes de los últimos 10 años, la inteligencia artificial en la astrofísica, los hoyos negros, el sistema solar, el telescopio espacial James Webb y la astronomía a través de la música y el humor. Sin duda, tópicos apasionantes que desde diferentes ópticas nos impulsa a estudiar y recrear la investigación de manera multidisciplinaria e integral. En este contexto, es preciso fomentar, impulsar e integrar en la formación de estudiantes la investigación, produciendo conocimiento científico de calidad y apto para la sociedad. El 10º Coloquio de Astronomía, Universo y Sociedad reafirma la colaboración entre las instituciones nacionales e internacionales, como la Administración Nacional de Aeronáutica y el Espacio de los Estados Unidos, el Centro de Astrobiología de España, el Instituto Nacional de Astrofísica, Óptica y Electrónica de Puebla y la Universidad Nacional Autónoma de México. Estas instituciones, que divulgan de manera independiente esta ciencia, nos acompañan con sus conferencias y aportes para el exitoso desarrollo de esta actividad académica. Para concluir, me permito expresar de manera personal mi alegría por la presencia de todos ustedes en este acto académico y mi invitación a disfrutar de la programación de nuestro 10º Coloquio Astronomía, Universo y Sociedad, de manera presencial y en los canales de la Feria Internacional del Libro. Muchas gracias.
A continuación, el doctor Marco Antonio Pérez Cisneros, rector del Centro Universitario de Ciencias Exactas e Ingenierías, nos dirigirá unas palabras y realizará la declaratoria inaugural del coloquio.
Muy buenas tardes, tengan todos ustedes. Qué gusto me da ser parte de 10 años de historia y 10 años de contribuciones de nuestro centro universitario al razonamiento científico, a la búsqueda de la verdad, a la difusión científica y más que nada a la divulgación entre la sociedad que tanto nos financia, que tanto nos da y que necesita respuestas de la Universidad de Guadalajara. Yo quiero empezar por saludar a todos mis compañeros del Presidium, agradecer a la maestra Laura, la directora del programa de esta Feria Internacional, decirte, Laura, que estamos contentísimos porque de que vamos a romper el récord, lo vamos a romper, ¿eh? Ya colapsamos la avenida de aquí afuera, no podía ni cruzar, así que estoy muy contento por ti, por la FIL, por la herencia del licenciado Raúl Padilla, que nos ha encomendado seguir adelante, y esa es la herencia también de la cual este coloquio forma parte. 10 años se oyen fácil, Alberto, nos sabrás decir, ¿dónde estás? ¿Qué tan difícil, qué tan complicado ha sido 10 años? Yo recuerdo la primera edición, nadie nos pelaba, ¿no? Tuvimos aquí los entusiastas, profesores del CUSEI y 2, 3 cuates de Alberto, ¿no? Hoy en día veo con alegría que tenemos un público distinto, un público entre académicos, expertos, profesores, coordinadores de posgrado, pero también tenemos jóvenes, estudiantes y público en general que busca respuesta. Respuesta a temáticas tan interesantes como el de los planetas errantes, que nos van a presentar en un ratito más, ¿no? Otros temas como los cuerpos menores en el universo, será interesantísimo escuchar en una mesa redonda las opiniones de nuestros expertos. Por supuesto, tema que nos preocupa a todos, la extinción masiva, y dirigido por la doctora Rosa Marta. ¿Dónde está Rosa? ¿No ha llegado por aquí, Rosy? No más al rato lo vamos a tener, yo a ella la conozco desde Cutonalá y sé de su capacidad. Y por supuesto, pues el impacto en Chicxulub, ¿no? Que va a ser interesantísimo oír los últimos acontecimientos científicos, pruebas. Y esto es nada más un ratito de astronomía que compartimos cada año, pero que ya tiene 10 vueltas al sol de que se realiza y nos llena muchísimo de orgullo. No me queda más que pedirle a nuestro director de nuestro Instituto de Meteorología seguir adelante, doctor, jefe de departamento. Sigamos acumulando, igual a nuestro director, sigamos acumulando la experiencia, conocimiento al servicio de la comunidad, que es el sentido que tiene esta reunión anual aquí en la FIL. Y sigamos celebrando que la Feria del Libro, pues de los libros quedaron los estantes y todos los millones de volúmenes que tenemos afuera, pero las ideas estos que van y vienen no tienen comparación. Por eso les agradezco mucho su presencia. Aquí estaremos siempre que podamos, siempre que me hablen, aquí estaré, ¿no? Compartiendo esta alegría. Y no me queda más que molestarlos y pedirles que se ponga todo el mundo de pie, porque vamos a celebrar todos los esfuerzos que este gran equipo hizo para estar el día de hoy, sábado 2 de diciembre, siendo las 4 o las 16 horas con 7 minutos, pues me permito a nombre de la Universidad de Guadalajara, particularmente de nuestro Centro Universitario de Ciencias Exactas e Ingenierías y de nuestro Instituto de Meteorología, declarar formalmente aperturados los trabajos de este coloquio y desear que nos salgan muchos nuevos talentos, nos salgan menos dudas, nos salgan más certezas, nos salgan nuevas esperanzas. Esa es la idea de compartir las ideas y desearles el mejor de los éxitos y el aprovechamiento. Felicidades a todos y que vengan los expertos. Muchas gracias.
Muchas gracias. A continuación vamos a despedir a nuestro presidium para dar inicio a nuestra primer conferencia magistral. Les pido un par de minutitos en lo que nos acomodamos, no se vayan, ahorita comenzamos. Gracias. Actualmente se encuentra en el Instituto de Ciencias Planetarias de Estados Unidos, NASA. Sin más, los dejo con el doctor.
Hey, good afternoon. Buenas tardes. I'm sorry I do not speak Spanish, so I'm going to speak in English, but I'll try to speak clearly, and I think there's going to be translation. So, I'm here to tell the story of the New Horizons mission to Pluto. And it's really, I think, one of the extraordinary stories of exploration of our time. An effort that took 26 years to go from just a dream, an idea, to an actual experience of exploring the Pluto system. And it's been my privilege to work on a book called Chasing New Horizons that I wrote with Alan Stern. And Alan Stern is the leader of the New Horizons mission. He's the what we call the principal investigator, the person who led that mission. And we decided after the success of exploring Pluto in 2015 that it was such a good story, such a crazy story of success against so many obstacles, that we wanted to try to tell the whole story of not just the science, but the human story of exploration, all of the people and the effort and all of the crazy obstacles to go around to make this mission happen. And in doing that, we wanted to try to illustrate what it really takes to make a mission happen. Because when one of these missions goes to a planet, you hear about it, you read about it, you see it on television, you see the success when it succeeds, but you don't always see the backstory, the years of effort, and sometimes painful setbacks, and just the large portions of people's lives that go into trying to make this happen. So we wanted to try to bring that alive. And so, in a way, this story starts with this little kid over here on the left. That's Alan Stern, my co-author and the leader of this mission, with his first scientific instrument, this microscope, when he was a kid. And then fast forward over here to the science team of the New Horizons mission, which Alan led, in front of the rocket, which in a couple days after this picture was taken was going to take off, leaving Earth on a 9-year journey to get to Pluto. But let me back up and talk about a little bit of the history of discovery of Pluto. That part of the story begins with this guy on the left. His name is Clyde Tombaugh, and he discovered Pluto in the year 1930. And what's interesting about that to me is that 1930 is not that long ago. There are a lot of people still alive now who were alive when Pluto was discovered. So this is not ancient history in that sense. And Clyde Tombaugh's story is really extraordinary because he grew up as a poor farm boy living in Kansas during the Depression. You know, the Depression, the economy was really bad. He was from a poor family trying to just keep their farm, working hard. And as a kid, he developed a fascination with astronomy, and he would go to the local library and get all the books he could on astronomy. And he had this dream, this fantasy of being an astronomer, but he had no way of doing it because he was a poor kid from a poor family, and there was no way he could ever go to college. There wasn't any money. So he knew he could never do this, but he built his own telescopes. That's one of the telescopes that he built, and he made his own lenses. He ground the glass to make the lenses, made everything by hand, And when he had free time on the farm, when there wasn't, too much work with the harvest and everything, he would go out at night and he would look at Jupiter and Mars, and he would make drawings, make sketches of what he saw. And he would mail those drawings off to observatories, just thinking, well, maybe somebody will see one of them someday. I sent them off, and then just didn't really think anything was going to happen. And then one day, when he was 22 years old, he got a letter from the Lowell Observatory in Flagstaff, Arizona. And it said, "Dear Mr. Tombaugh, we have seen your drawings of the planet Mars, and we are very impressed. We are hiring an assistant astronomer. Would you like the job?" And of course, the answer was yes. So he went off. He had never left Kansas before. His mother packed him some sandwiches. He packed up his astronomy bags. He got in the train, and he went to Flagstaff, Arizona, to start this job. And there, they told him that his job, he was being assigned to look for what they called Planet X, which was the idea that maybe there was a planet that had not been discovered yet, out beyond Neptune, a new planet. And his job was to search for that planet. And a lot of older astronomers said, "This is crazy, kid. There's nothing out there. You're wasting your time. They're giving you a foolish job." But Clyde searched, and he took pictures of the night sky every night for more than a year, looking at little parts of the sky and trying to find something that moved from night to night. Because the stars don't move from night to night. But if there's something in that picture that moves from night to night, and if it's moving in the right way, then it might be an undiscovered planet out beyond the orbit of Neptune. So he searched and he searched for over a year, and then in February of 1930, he found something. And you can see what he found here. Because, see, on the left is from January 23rd, and on the right is from January 29th in 1930. And you see all the stars are the same in all the images. But there's one thing that's moving that's not the same. Between these 6 nights, you see where the arrow is. That one thing is moving. And Clyde said, "Aha, I found it." And then he went back the next month after the next full moon to make sure, because he could predict where it should be, and it was there. So he knew he had found a planet. And then he went and he told his boss, "Hey, I found your Planet X," and the rest is history. So, whoops, except I've lost my, he succeeded, I failed. No, we'll get it back up. 1 second. Rocket science. Hopefully it won't happen again. So anyways, yeah. He found it. And that was 1930. And so we knew there was a very distant object out there. Is it a planet? Is it not a planet? It depends on what you mean by that word. We're not going to get into that silly debate. But it was an extraordinary finding, much farther than anything had ever been found before. And for a long... Oh, no. Maybe it didn't like that slide. I'm going to go on. Sorry. Maybe that's that link slide. Everybody pray. So at that point, we knew it was out there, but we didn't know anything about it. You couldn't see any detail. It's just a dot. And so you could use your imagination and imagine it. Maybe it was like another Earth. Maybe it was like an asteroid, maybe. Nobody knew anything about it. So that meant you could fantasize, and there was a lot of science fiction about it, because between 1930 and the beginning of the space age, when we started to have better telescopes, all we knew was that there was something out there, and we knew a little bit. We could start to tell it was small and bright, but didn't really know much about it. So because of that, there was a lot of science fiction about Pluto. People could just imagine anything, and you couldn't say that it was wrong. So there's all kinds of stories about aliens on Pluto, and Pluto as an outpost to the stars, and all these fun ideas when we didn't know anything. But then, of course, in the space age, we started to make more discoveries, which put Pluto in a new context. And people started to get the idea that maybe we could go explore Pluto. And the first idea about this was in the 1970s. There was this idea for a mission called the Grand Tour, because it turns out that once about every 200 years, the solar system lines up in an interesting way where, lost my brace? Where I'd get excited and I start throwing things. The solar system lines up in an interesting way where Jupiter, Saturn, Uranus, and Neptune are all lined up in the right way, so that if you send a spacecraft to Jupiter, you can use the gravity of Jupiter to send it on to Saturn, and then use the gravity of Saturn to send it on to Uranus, and then on to Neptune. So that's what's called the Grand Tour. You can use the planets, each one, to get to the next one. But the orbits have to be in the right place, and it's only about once every 200 years that they line up in the right way. But it just so happened that in the 1970s, the planets were going to be lined up so that we could, if we launched in time, if we launched by the mid to late 1970s, we could get to all the planets through a grand tour. So scientists realized that in the 1960s, when we were just starting to launch spacecraft for the first time. You know, the first orbiter of Mars was in 1971, and the first lander on Venus was in 1976. You know, so sort of around that time when we were doing all these first things in the solar system, they said, hey, if we could do this, if we could launch it on time, we could go visit all these planets in the Grand Tour, including Pluto. And at first, Pluto was part of this plan, but then they proposed it to NASA, and NASA said, no, we can't do that, it's too much money, you can't. And then the scientists said, well, wait a minute, what if we do something simpler, and we just go to Jupiter and Saturn, and not the rest of the solar system? And NASA said, okay, and that was the origin of what was called the Voyager program. And they dropped Pluto from the plan, and in fact, they originally dropped Uranus and Neptune from the plan, and it was just going to go to Saturn and Jupiter. But the scientists were very clever. They built it so that it possibly could survive and keep going to Uranus and Neptune, but they didn't really, they told NASA, okay, we'll just go to Jupiter and Saturn, but they knew that it was possible that if things went well, they could keep going. And of course, that's what happened. In the Voyager program, there were 2 spacecraft. It was very successful. It launched in 1977. It got to Jupiter in 1979, Saturn in 1981, Uranus in 1986, and Neptune in 1989. And it was amazing. It was our first close-up visit to all these planets and their moons, and we learned so much. The Voyager mission was wonderful. For the scientists of that time, and just for humanity to learn about these planets for the first time. But then in 1989, Voyager was over. At least it visited its last planet, Neptune. And this is one of the last pictures from Voyager at Neptune. It's a crescent because it's looking back towards the sun. It's already past Neptune, and so the angle is just a crescent. It's mostly you're looking at the night side because you're past Neptune looking back. And off the corner of Neptune, there's a little moon. That's Triton, Neptune's moon Triton, which you can also see as a crescent. And Triton was the last place that Voyager visited. And it was very sort of a little bit sad, this Neptune encounter. I was a student then, and it was sad because Voyager had been this wonderful thing. Every few years there was a new planet to look forward to. And now that was it. No more planets to look forward to. And it was sort of done. And Triton was amazing. It was the last place that Voyager visited. And it's a very sort of Pluto-like moon. It's got an active surface of nitrogen ice and an atmosphere and geysers on the surface, all kinds of crazy stuff on Triton. And it's about the same size as Pluto. And so it got some scientists thinking, some young scientists thought, why don't we send a spacecraft to Pluto? And especially the scientists that were sort of just finishing school at that age, around 1989, some of them said, hey, NASA, we want to send a mission to Pluto. And all the older scientists basically said, no, that's never going to happen. It'll cost too much money. It'll take too much time. It's too far away. It's probably not that interesting anyways. It's just a little ice ball. Sorry, kids. Can't do it. And Alan Stern, who I mentioned, had just finished grad school at that time. And he and a bunch of young scientists got together and they formed this group that they called the Pluto Underground, which was like their sort of rebel alliance, where they said, hey, we're going to somehow find a way to do this. And at first, all the older, more mature, wise scientists said, no, you can't do that. But they made a plan, and they kept going. And they figured out how to get support from scientists, and they held meetings about Pluto, and they did studies. And slowly, they started to get support for this, what seemed like a crazy idea, to send a spacecraft to Pluto. And one thing that helped was I'm going to go back to that one in a second. But one thing that helped was that in the 1990s, we discovered something that made a mission to Pluto much more interesting, which was that we discovered that, we discovered that Pluto is not alone out there. We thought that before, our picture of the solar system was just that, there's the inner solar system where Earth and Venus and Mercury and Mars are right in the inside. And then there's the outer solar system with Jupiter, Saturn, Uranus, and Neptune, and that's it. And then there's this crazy Pluto on this weird, tilted, big orbit, and we thought that was it. But then we discovered in the 1990s all of these new objects, which we call the Kuiper belt, that Pluto is part of this whole new zone of the solar system that we didn't know about before then, where there's millions of icy objects out there. And Pluto is just the biggest one of this whole realm, previously undiscovered, sort of a third zone of the solar system. And that meant that if we could explore Pluto, we'd be learning something important, because these are icy leftovers from forming the solar system. Sort of when the planets formed, all the little pieces ended up in planets, except for the pieces that didn't end up in planets. A lot of them ended up out here in the Kuiper belt. So it's like the leftover stuff from building the planets. So if you can get out there and explore the Kuiper belt, you can learn some important things about how the solar system was built. So this discovery really helped. But it was still really frustrating. They kept proposing to NASA, and NASA said, okay, go on to the next step. And then they'd go on to the next step, and NASA said, no, there's no money, it's canceled, you're done. And they said, no, we're not done. They got people to write letters to NASA, they got the public to write letters, and they kept trying again and trying again. And so one way to think about this is the famous Charlie Brown with Lucy and the football, where Charlie Brown's going to kick the football, and he's all excited, and then at the last minute, Lucy pulls it away, and he falls on his back. And this happens over and over again, and he never learns. So it felt like that for a while, where they just kept trying, and then NASA would pull the football away, and they'd go flying. But they kept at it. And amazingly, they started this in 1989, this effort. And in the year 2001, NASA gave the green light for this mission. And the mission became New Horizons. But here's what was tricky. They finally said yes in 2001, but just like that grand tour had to launch by a certain date so they could use the flybys of the planets, it turned out in order to get to Pluto, within only 9 years, and 9 years sounds like a long time, but that's the shortest trip you could make to Pluto, that you had to launch by 2006. And you had to launch by 2006 because Jupiter would be in the right place, so that you could get to Jupiter and then use Jupiter's gravity to get to Pluto. So it was all of a sudden they said, yeah, you can do it, but you only have a pretty small amount of money for a spacecraft to get all the way there. And if you don't launch by 2006, then you have to wait another decade, another 10 years. So the race was on to build this thing, and here it is being built, New Horizons. And you can see one of the things they did that was innovative was it's a very small spacecraft. I mean, if you compared this to the Voyager's like 10 times that big. Voyager would fill the room from me to, the back of the room there. It's huge. Whereas New Horizons would fit right here on this stage. It's about the size of a piano. Fit half of this stage. It's about the size of a baby grand piano. And not very massive, using much more advanced technology than they had for Voyager, so they could make it smaller, they could make it cheaper and lighter. And the scary thing, though, is there's only one. They only had enough money to build one, whereas with the Voyagers, there was Voyager 1 and Voyager 2, and a lot of the previous spacecraft, there was Mariner 1 and Mariner 2. So if something goes wrong, then you have a backup. And this was done always before, but with New Horizons, there was only one. But they had backups of everything on board. So there was a backup computer and backup, all the components, the transmitters. But still, you only had one chance with this. And you can see here, this is a nuclear power source. You're going that far from the sun, you can't use solar power. So there's plutonium in here, a nuclear power source. It's not loaded yet with the plutonium. They do that at the last minute. This is the antenna to communicate with Earth. It's wrapped in gold foil to protect it from radiation and from particles. And this will just show you some of the parts. I won't go into the details of all this, but basically what you see here, all these are the different scientific instruments, the eyes and the ears and the nose, to sense, so that New Horizons can sense what it finds out there. So for instance, Lori here, this is the end of a telescope. There's an onboard telescope inside pointing out in this direction. And Ralph and Alice, these are what we call spectrometers. Alice looks at infrared light, which is the very short wavelengths of light that can tell you things about what kind of gases there are there. And Ralph is an infrared spectrometer, which tells you about the longer wavelengths of light, which can tell you what kind of ices you're seeing on the surface and if there's any organic molecules and so forth. SWAP and Pepsi, these are instruments that measure the magnetic fields and the particles out there. So all these different instruments are basically the eyes and ears of the spacecraft, so it can measure what it encounters out there. Anyways, so there's young Alan, and here's Alan on the day that New Horizons was put into the rocket and fueled up, and the door, right after this picture, the door was closed, and nobody ever saw New Horizons again. This was the last anybody ever saw it. The door was closed to the spacecraft, and it was going to be launched off Earth, and bye-bye. I hope it works. And as I showed you before, this is the science team right before launch in front of a really big rocket. This rocket is like a 40-foot high building. It's a really powerful rocket. It's an Atlas V with these solid rocket boosters strapped on the bottom, which give it extra thrust, and an extra rocket stage on the top. So it's a really big rocket with a really tiny spacecraft, which is good because you have to go really fast to get to Pluto. In order to get there in only 9 years, you have to have a powerful rocket with a very low-mass spacecraft, so you can launch really fast, and then you need to get to Jupiter just right to get the gravity pull out to Pluto. And so this was, in fact, the fastest launch ever off of Earth, the fastest rocket ever launched off of Earth. Here's the launch. I was there that day. It was really powerful, really loud and bright and intense. I mean, it's sitting there on the pad, and you're waiting, and it counts down, and then something goes wrong, and they have to stop the countdown and you come back again and try the next day. This happened for 4 days in a row. And then there's bad weather and they stop the countdown. And then there was somebody in a boat near the shore, so they had to stop the countdown. All these things, you know. And then finally, the count is getting lower and lower, and you're like, wow, it's really going to go this time. And then it does, and it happens so fast, and then it's bye-bye New Horizons forever. In fact, that's me. I was younger then. And that's my last ever glimpse of New Horizons. And you could see I was kind of emotional at that moment. Anyways, so New Horizons, just to give you an idea of how fast it launched, when the Apollo Saturn V rocket went to the moon, it took the astronauts several days, 3 days to get to the moon. New Horizons got to the moon's distance in 9 hours. And then it was basically moving 1 million miles a day. And it got to Jupiter in 1 year, the fastest ever trip to Jupiter. And just, this is just sort of a schematic of, it launched in 2006, it got to Jupiter in 2007, and then it was another 8 years to get to Pluto. And that was very challenging, having that long a journey, for a number of reasons. Here's one reason that you don't always think about. If you launch a spacecraft and you're not going to get to your destination for 9 years, what if some of the people who know how to run the spacecraft are not around in 9 years? Or what if they've forgotten things? And so one thing they did was they had everybody who works on the spacecraft make a video for themselves in 9 years. They said, hello, myself in 9 years. Here's everything I know. Here's what I do. So that if it's you, then you remember. If it's somebody else with your job, maybe you're not alive anymore, or maybe somebody else has the job, then they can watch the video and they learn. Another thing they did was that had never been done before was they hibernated the spacecraft. They put it to sleep in order to save resources and in order so it didn't take as many people to run it on the ground. To save money, they needed a smaller team. But that was scary. That had never been done before, because if you put it to sleep, you've got to make sure that it's going to wake up. So they tried it. First, they hibernated it. They put it to sleep for a couple hours, and then they did it for a couple of days, and then eventually they learned they could do it for many weeks at a time, put the spacecraft to sleep, and then get it to wake up. And that was a way that they not only saved resources, but they didn't wear out the spacecraft in 9 years. You know, if you have a television and you leave it on for 9 years continuously, it may stop working. But if you turn it off a lot and then turn it on occasionally, it's going to work longer. So that was the idea behind the hibernation. Anyways, so they got to Jupiter, and they did some cool science at Jupiter, and they tried the spacecraft. They practiced at Jupiter using all the instruments, and they discovered some crazy things. Like if you look at, this is Io, Jupiter's moon Io, and you can see this little plume at the North Pole of Io. There was a volcano going off on Io when New Horizons flew past Jupiter, and they actually caught it in the act, and they got movies of that volcano and some really cool discoveries. But mostly they just practiced with the spacecraft and made sure they knew how to run it so that when they got to Pluto 8 years later, hopefully everything would work. And then there were some other adventures along the way. In the interest of time, I won't go through all of it, but there was one very scary moment 2 weeks, or actually less than 2 weeks, before they got to Pluto. After 9 years of traveling across the solar system, they completely lost contact with the spacecraft. It went dead. They were like, hello, hello, and nothing. And it was really, really frightening. And they figured out that there had been a computer crash on board. And they had to switch to the backup computer, which meant they had to send all the commands for the flyby up to the spacecraft and reload them with just about a week to go before the encounter. And there was almost not enough time to do that. You have to remember that when you're that far from Earth, it takes a light signal 4.5 hours to get just from Earth to Pluto, which means the round trip is 9 hours. So if you just want to say, hello, New Horizons, are you okay? And then it goes, yes, I'm okay, I'm here. That takes 9 hours. And then if you want to say, okay, switch to the backup computer, and then 9 hours later say, okay, I'm on the backup computer, and you don't have that many hours left. So they worked round the clock, and it was really scary, but they got it working. And on the day of the encounter, it happens really fast. It's going at 50,000 miles per hour through that system, and you have, one chance. It's a flyby. You have one chance to point the instrument at Pluto, point the instrument at Charon, the big moon of Pluto, or at Styx, Hydra, Kerberos, or Nix, the small moons, and all this. It's like choreography, like a dance. It's all programmed in advance. You're going to turn this way. You're going to turn this way. You're going to do this measurement. You're going to, it all has to work perfectly, and you get one chance. You can't go back, and then you're off into the solar system. Anyways, the good news is that they had done their homework, and everything worked. And here is the team looking at the first high-resolution image of Pluto. And one of the amazing things about New Horizons and Pluto was that not only did basically everything work, and beforehand I was going, and a lot of people were going, boy, I sure hope this works. But there was also this other fear that I had, and a lot of people had, but maybe people didn't say it out loud so much, but the fear was, what if Pluto is boring? I mean, seriously, we get all the way out there, and maybe it's just sort of an asteroid or has a bunch of craters, and it would be cool. It would be cool, but what if it's not that exciting to look at? And the amazing thing is that Pluto exceeded all our expectations. It's really beautiful and complex and strange and full of just mysteries and lessons. And you can see the science team reacting here. This is not staged. This is somebody in the room taking a photograph, and they're all going, look at that, look at that, look at that. There was a lot of joy that day. This was some of the team. At the moment we got the message back that the encounter had been successful. Because again, with that 9-hour delay, there's a period of many hours where you know that the spacecraft has already gone through the Pluto system, but you don't know if it worked. You know that something has happened out there, and you don't know if anything worked. So then when the signal comes back and it says, the first thing that you learn is that the computer memory of the spacecraft is full. That's the first thing you learn. And that's good, because it means that there's data there, that they got something. And then you start to get the pictures back, and it looks amazing. So this was the moment they learned that, in fact, that New Horizons had data, and something had been gained. So here's sort of a schematic showing before and after of that flyby, what we knew about Pluto. We had these very vague markings from the best images we had from the Hubble Space Telescope looked like this. And then the amazing thing about a flyby is that it's just a moment when you go from knowing nothing to knowing everything, or a lot. The increment, the change in knowledge on that day when you get those first images back is just so huge. So that was pretty exciting. Here's one of the better images, and there's so much to look at here. I'll tell you in a little bit more detail, but you can see, this is the feature that was called the heart, because it kind of shaped like a heart, and it's like the first thing we saw from a distance is like, oh, Pluto has a heart. It's so sweet. But also, it's very bright and very smooth, this feature. And that's really interesting, because it means that something is active, that it's, I don't know why that's advancing. Something's active, it's young, it's not ancient. There's something changing there. If you see a surface like the moon that's full of craters, then you know it's ancient. It's been sitting there and getting hit over billions of years, it's old. But when you see a surface that's fresh and smooth and there's no craters, that tells you there's some activity, there's something going on. And that was really surprising for Pluto, because it's so far from the sun and so cold and made out of ice. What's the heat source? What's the energy? Why would it be active? And then you can also see this composite with Pluto and its very large moon Charon, which is about half the size of Pluto, so for, it's a really, I mean, Pluto's a small planet, but it has a very giant moon for the ratio of size of Charon is really big compared to, it's half the size of Pluto. That's very unusual to have a moon that's half the size of the planet. So Charon was another really interesting place to explore. Here's a close-up of Charon, and you can see a few things. One is that there's this gash, this giant canyon system going across the whole moon. And we think that's because when Charon formed, Charon's mostly made out of water ice. We know that from that infrared spectrometer measurement. It's water ice. And we think that when it formed, the freezing of that water made it expand. Just like you put a bottle of water in the freezer and it'll crack open, it expands. So this is like basically the interior of Charon. When the water froze, when it formed, it expanded and it cracked open, basically cracked the crust. Another strange thing about Charon is that the North Pole is stained red, which was surprising. And it turns out that when you look with instruments, that red stuff is organic matter. Which is interesting, of course, because we are organic matter. It's very interesting to learn about where there's organic matter in the universe because it relates to the question of where there could be life. I'm not saying there could be life on Charon, but the organics are interesting. And where did they come from? Well, this is really strange, but it has to do with Pluto. Pluto's atmosphere is made out of largely methane, which is just, a carbon with 4 hydrogens. It's a very simple organic molecule. And it turns out that methane from Pluto is escaping, and some of it is condensing out on the pole, the North Pole of Charon, because that's the cold part of Charon. And then that methane is getting hit by radiation from the sun and turning into organic molecules. So it's this weird thing where the methane is coming from Pluto and ending up as this organic red stain on the North Pole of Charon. Nobody expected that. There's also 4 small moons of Pluto, Styx, Nix, Kerberos, and Hydra, and they're sort of tiny little irregular shaped. Oh, come on. It doesn't like my movies. I like them, but... The irregular moons of Pluto, I'm going to skip that slide because it doesn't like it. So, let me talk just a little bit more about what we found on Pluto itself. This is a close-up of that area that I described as the heart, which we call, it's named after Clyde Tombaugh. Remember the kid who discovered Pluto? So this is called Tombaugh Regio. And the smooth part of it is called Sputnik Planitia, after the first ever spacecraft, Sputnik. A lot of the features on Pluto are named after explorers and craft, exploration ships and craft. So that's why Sputnik and Tombaugh. But anyways, this smooth stuff, it turns out, is a giant glacier of nitrogen ice, frozen nitrogen, which is just hard to picture because, I mean, you're familiar with nitrogen. It's in this room. That's what we're breathing. Most of the air on Earth is nitrogen. But we don't think of it as ice. But you take any gas and you cool it enough, and it'll become a liquid, and you cool it more, and it'll become an ice. So if you take nitrogen, just like the nitrogen in this room that we're breathing, and you bring it out to the distance of Pluto, and it gets that cold, you get nitrogen ice. And that's what a lot of Pluto's surface is made out of. And it turns out that the reason it's so smooth is that nitrogen ice flows really easily without much of an energy source. And it turns out there's enough energy coming from inside Pluto because Pluto is half rock and half ice. And the rocky part has a little bit of natural radioactivity. Not much, but it turns out that nitrogen ice is so soft that even that little amount of heat gets it to flow. And that's why there are giant nitrogen glaciers on Pluto, something we really didn't expect. And that's why so much of the surface has this young, active look. Here's a close-up of that nitrogen glacier, and you can see these sort of cells shaped. This is like because of like convection Think of when you put something on the stove, you're making some sauce on the stove and you heat it up and it sort of bubbles and turns over. That's what's happening here in slow motion with this nitrogen ice. We call that convection, and that's what makes these shapes here, something we really didn't expect. And then on the outside of this, you can see these mountains. Those are very tall mountains of water ice. The mountains on Pluto are made out of water, and the glaciers are made out of nitrogen. So familiar materials to us, but in very unfamiliar forms. There are other areas of the surface that are more ancient and have some craters. There are areas with this strange shape, which turns out to be methane snow. There are snow-capped mountains on Pluto, but the mountains are made out of water ice, and the snow is made out of methane, or like natural gas. So again, familiar forms made out of stuff that we don't think of in that role because the conditions are so strange. You see these places where the surface is pitted because of ice evaporating in the solar radiation, and the very rough mountains on the edge of this plateau. I'm going to wrap up here now because I want to see if there's a little bit of time for questions, but I wanted to show you just a couple more pictures. One is, this is actually my favorite picture of Pluto from New Horizons. This was taken 15 minutes after closest approach. And remember how fast it was going. So even 15 minutes after closest approach, you're already looking back towards the sun, which is why the shadows are long here. And you can see so much in this image. You can see there are places where there's flow of nitrogen on the surface. You can see these very rugged mountains and their long shadows because we're looking back towards the sun. And then off the surface of the planet, you see these layers of haze. And it turns out that Pluto, even though it has a very thin atmosphere, that atmosphere is full of clouds and hazes made out of things that are happening to the methane in the atmosphere, reacting with sunlight and making organic molecules, and a lot of really strange and interesting chemistry happening in the atmosphere and making these hazes. And then one of the really delightful, one of the last surprises when we flew past and looked back at the sun. Now you're looking, the sun is behind Pluto, so you're seeing it illuminated through the atmosphere of Pluto, and it turns out the sky is blue. Nobody expected that either, but when you see it this way with the sunlight coming through the atmosphere, we see this beautiful halo of a blue sky, and that was our last image of Pluto from New Horizons. New Horizons wasn't done, though. And there's Alan the next day holding up the New York Times with that picture of Pluto on the front. And if you think of that little kid with the microscope and then the 26 years of effort from when he and his team first proposed this from 1989 to 2015, then that's kind of an extraordinary moment. But New Horizons wasn't done because it wanted to keep going after Pluto and explore. There's all those little objects in the Kuiper belt. But the question was, could New Horizons get to one of them? Could we discover one that New Horizons could reach? Because it couldn't go anywhere in the Kuiper belt. After Pluto, it had a little bit of fuel. It could change its trajectory, change its path a little bit, but only if we found an object on that path. And so there was this big effort using all the telescopes of Earth and the Hubble Space Telescope, and they had to find an object in time before we got to Pluto so they could correct the path at Pluto to get there. And it was looking like we might not find it. And I won't tell the whole story now, but in our book, Chasing New Horizons, we describe it. But there was a lot of drama. And just at the last minute, using the Hubble Space Telescope, they found this one object they could get to, and it was called Arrokoth. And more than a year later, and 1 billion miles later, after Pluto, they managed to fly by this one other object called Arrokoth. Oh, whoops. Sorry. I forgot. Okay, I'm going to wrap up. Thank you. This was just some of the fun pop culture stuff that came out of that Pluto encounter, where people made GIFs of the Little Prince and turned it into the Death Star and, all kinds of fun Pluto stuff. But I was talking about Arrokoth. This was the sort of dessert after the meal of Pluto. We managed to get to this one other object, and it's a really interesting place. It's about 20 miles across, and it turns out it's what we call a contact binary. It's two pieces that kind of squished together and formed one compound object. And this is really interesting because it gives us clues as to how the planets formed. These low-velocity collisions of smaller objects forming larger objects, that's a process we call accretion. And it's how we kind of think the planets formed, but this was our first evidence of actually seeing it in action. So this was a wonderful discovery, and that's called Arrokoth, and we're still studying the images from this. The last thing I want to show you is something kind of moving. Clyde Tombaugh did not live to see the mission go to his planet. But he was alive when they started planning it, when Alan and his friends started planning this mission. And Clyde asked them, if you're able to do this and I'm no longer here, could you send some of my ashes to Pluto? And they did. And there's Clyde, and here's a little container on the spacecraft. It says, "Contain herein are remains of American Clyde Tombaugh, discoverer of Pluto and the solar system's third zone, Adele and Muron's boy, Patricia's husband, Annette and Alden's father, astronomer, teacher, punster, and friend, Clyde Tombaugh, 1906 to 1997. And by the way, Clyde's kids were at the launch that are mentioned here, and his wife, Patsy, she's not alive now, but she was there at the launch. And so Clyde, a bit of Clyde made it out to Pluto with this. And with that, I will stop, and I think maybe we have a minute for questions. Yeah. Thank you. Sure. Is that okay?
Bueno, agradecemos. ¿Tenemos tiempo para una pregunta? Si alguien. Yeah.
Hello.
Okay,
my name is Carlo. Thank you. It's a pleasure and a privilege standing here and listen to you. 40 minutes. But it's amazing because I was telling this guy that I don't know his name yet. I'm sorry. But I was telling that when I was 6 years old, I got obsessed with Pluto. In an encyclopedia from my dad that was from the universe from the 90s. So the pictures that you show from Jupiter, I saw them when I was a kid. But I didn't know about this conference. That's something about me. But I'm very glad that I'm here, and it's very historical. I think the people here and the people outside here don't realize the importance of this mission, what have changed for humanity. And it's going to change because it's something that is developing as we speak. And I was wondering, my question is, so this means that the Kuiper belt, the solar system is still evolving, is still creating itself like an eye, expanding since the sun all the way around, and it's going to continue to create more planets, right? Exoplanets. That's my question. Why is that happening? Why does that mean that we're like the younger side of the solar system, but it's going to continue, right?
Well, first of all, thank you so much for your comment about the mission and your experience of it. That means a lot. And one thing that was wonderful, by the way, about this mission compared to Voyager, when Voyagers happened in the 1980s, we didn't have the internet. And so you had to be there in the room to see the pictures, right? And you could maybe see them the next day in the newspaper. But with New Horizons, because we had the internet, it was on Twitter and whatever, and people all around the world saw it at that moment. And we got messages from, people in India and Africa and, everywhere saying that they were experiencing this together. So it had this feeling of like, now we can do this for more of the people of Earth. So it's really great hearing your story. As far as whether the planets are still forming, the answer is not really, because the density of that material is less. When the solar system was young, there was much more material, and it was all colliding, and it was much more dense. And then when the planets got big, because their gravity gets more powerful, a lot of material gets ejected out of the solar system. So there's not much density of material. So out in the Kuiper belt, there's a lot of objects, but remember the Kuiper belt is huge. And so the chances of them colliding with each other are very, very small. So it's not really true. I mean, once in a while maybe there's occasional collision, but it's not really true that the planets are forming anymore because that density is just too low.
Oh, thank you.
Sure.
Thank you.
Okay, yeah.
Una última pregunta. Tenemos tiempo para una más.
Thanks.
Ah.
Thanks. How many estimate in Kelvin graph in supervised Pluto?
I'm sorry? I didn't understand.
Estimate in Kelvin graph.
Oh, how cold is it? Yeah. It's about, well, it varies between the different parts if it's bright or dark, but about something like 40 degrees above absolute zero. So something like minus 200 Celsius, yeah. Very cold. Yeah. 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 Okay. Thank you. Yeah.
Agradecemos por favor al doctor. Thank you very much.